5th September. And registrations are just 10,000 naira for registrations. And for our Ghanaians, students is 100 GHC. And you can also pay in dollars for other students around the world, which is $7. And the registration link is it's going to be sent to the chat right now. Okay. So this is the registration link for the summer program. Please do well to register for the summer program to put yourself in an advantage over every other person that you may know, because this is going to redefine how you understand ISO management systems. And I'm sure you're going to be getting all the updated structures. So
Can I ask you a question? If you're registering for this program, will AI automation class have ended?
yes.
Okay, because I'm already running 2 classes with
Okay, AI
them,
automation
so that it won't be too much
and
for me.
no,
All right.
by the time the summer program starts, our AI programs will have ended, so we'll just continue on with the summer program.
Okay. All right. Thank you.
All right. So without wasting more time, I would like us to give probably 2 to 3 minutes for others to join on the call. And today we're going to be talking about saving and scaling models, and we'll be having one of our lovely trainer, Mercy Ijoma Vicent. But before I introduce the trainer, I would like I'll call I'm feeling like I should call the name randomly. I just want to call one or two people to, let us know what they have been able to learn so far from AI automation. Let me start with Amaka. Please, what can you, in a few words, let us know what you have been able to get from this course, AI automation specialist?
Good morning, everybody.
Good
When I
morning.
started the class, I was struggling with a lot of things in my job. Sometimes I had to do a job for like 3 days, but since I started it, I automate a lot of my job and just proofread, correct. So it has made my job a lot of very easy, very easy, very easy. I automate a lot of my jobs now.
That is amazing. That is amazing. That is amazing. Thank you very much for that. I would like to call one other person before we proceed. I would like to call on Patricia, if you can hear me. Patricia, can you give us in a few words what you've learned from AI automation, especially so far? Hello, can you hear me, Patricia? All right, I'm not okay. She says she's not able to speak at the moment. All right. Okay, that moves on to the okay, you can also type your answers actually. You can type your answers. Feel free to type the answers. And I would like to ask Comfort. Comfort, what would you say in your own opinions have you learned in a few words, have you learned from AI automation specialists? Please kindly acknowledge if you can hear me loud and clear, because I'm not getting any response as of now.
Yes, we can hear you. And please, you're able to unmute your mic and speak, please, everybody. Thank you.
All right, I can see that we are already cutting into our time for a bit, so let's go back to introducing our trainer for today. Our trainer for today is Mercy Ijoma Vicent. Mercy is an AI specialist dedicated to build intelligent solutions that make everyday process easier and more efficient. With a background in software development, she's focused on creating solutions that are both effective and meaningful. And we'll be having the honor to have training by Mercy Vincent today. Please, can you hear me? Miss Mercy, can you hear me? Hello, Miss
Yes,
Mercy.
yes, I can hear you. Yes, I can hear you.
All right, very good. So I would like us to appreciate our trainer in the chat box, or you can also use your emojis so she can proceed from here. Let me stop sharing so you can proceed.
Good morning, everyone. Good morning, everyone. Please confirm if you can hear me. If you can hear me, I want to see reactions so I can be sure that I'm audible enough.
We can hear you.
Uh,
Good morning.
okay, I can
Oh,
hear you, but it's a bit low from my end. I don't know if it's only from my own end, but it's a bit low, but I can hear you.
You just need to increase
okay,
my volume.
okay. Okay, good morning. Good morning, everyone. So today we are going to be learning on model saving and scaling. And I'm going to be your trainer for today. So I don't know if anyone has an idea of what model saving is. If there's anyone, you could just go to the chat bot and then just tell me if you have what you understand by model saving. Model saving. Is there anyone? Okay. So I'll just proceed. So model saving, as the name implies, is the process of training machine learning models to make predictions. So basically, it's just the process of training machine learning models to make predictions on data. In our previous classes, we've trained a lot of models, we've done testing, and we've seen how models are being trained. So model saving is just that process of training those models to make different predictions. And we have different kind of predictions, evaluations, and that's what I'm going to be walking us through on. So give me a moment, let me share my screen. So that's for model saving. And then model scaling, I'll try to explain it in the layman English in a way everyone can understand. So model saving, as I said, is place of training those models. While model scaling is the ability of those systems we've trained to be able to handle large amounts of data as time goes on. So scaling, we're making the systems to have the ability to handle bigger amount of data or bigger amount of requests without breaking. So as the data grows, the system should still be able to work effectively. That's what we that's what we call model scaling. That's okay. So that's model scaling. And I'm going to walk us through on the different evaluation metrics because in our last class we trained two types of models, A and B, and we're able to see the evaluation metrics. That's what the model was able to evaluate based on the trained data. We're able to see different evaluation metrics. So I'm going to walk us through on what those evaluation mean and then how so I could be able to understand those metrics when we train our models, and then we are seeing yes, no, should be able to understand what the model means by that. And then when we are seeing different numbers, should be able to understand if our model is actually training correctly, or if if there's a wrong prediction. So yes, so those are the metrics evaluation. So the first one I would be explaining is confusion metrics. So you might see the word confusion metric, and then you might think is to confuse the model, but no, that's not what confusion metrics is. So confusion metrics is to understand how the model makes mistakes, because our model will definitely make mistake, and then we need to understand if these mistakes are increasingly high, if it's something that we need to, if there's a cause for alarm. So that's what we use confusion metrics for, to be able to understand how our model makes mistake, and then we'll be able to use those mistakes to know how to train the model, how to keep training the model. So it's a simple table that compares what the model predicted and what the actual answer is supposed to be. So it looks like a table, and then it shows us the different prediction. So the first one that we're going to be talking about is the true positive. So we have true positive, because when your model trains those data and it's going to give a result, and then you see something like true positive, and then you see false positive, and also there's false negative, true negative, and those things, these key outcomes are very important to understand. These key actions outcomes rather are very important for us to understand, so we could be able to know if there is a cause for alarm. So first, when the model predicts yes and it is actually yes, that means the model is giving us a correct prediction. We call it a true positive. If the model is meant to detect if an object is actually a chair, and it was able to detect that yes, this is a chair, so it's going to give us a yes, and that means it is a true positive. Are you with me? So that means it is a true positive when it's able to give us the correct answer. It's able to know if it is also no, and it's able to tell us that it is no. It's also giving us the correct answer. So that's when we know that okay, this is a true positive. And then for false positive, so now let's look at this false positive. Just like how true positive is, false positive, just like how true positive is when the model predicts yes and it's actually yes. So in this term too, false positive is also when the model, when it is yes, and then the model is predicting no. So we'll say that it is a false positive. Is everyone with me? Please, if you have any question, you could just go to the chat box and then type in your question so I could see it and answer. So the false positive happens when the model predicts yes, but the actual answer is meant to be no. So if we trained our model to be able to identify, if we train the model to be able to identify that it is a chair, and then we placed a table, and it scans through it, and it's supposed to tell us no, it is not a chair, but it's telling us yes. So, and meanwhile, the answer is meant to be no. So in this term now, it's supposed to there's supposed to be a cause for alarm, because it has it's giving us a false answer. I'll also give another example. If we have a fraudulent system, if we have a fraudulent detection system, and this system is meant to identify fraud transactions, and there is a transaction which is okay, it's meant to identify a fraud transaction, and then there's a transaction which is not fraud. It is a true transaction which is not fraud, but the system is now identified that this is a fraud transaction. The system did not do bad because it was trained to identify fraud transaction, but now it's a transaction that is not a fraudulent transaction, and it is saying it is a fraudulent one. So in this case, it is always very critical, and this kind of errors can be so costly because it can lead to unnecessary actions, like it could lead to blocking the account when it's not meant to be. Because I know most of us would have had situations like this whereby we try to access our bank account, or not just bank account, access any of our mutual accounts, and you are the rightful user, but the system is telling you you are not the right user. Or maybe there's a face detection and you put in your face, but the system is not able to detect that it is you, and it is saying no. Meanwhile, it is meant to detect that it is you, and it could lead to the system blocking your account. And this kind of things are always very critical, and we need to there are actions that we need to try to avoid. So that's why we need to identify this kind of mistakes when training our model. And then also we have the false negative. Also, we have the false negative. So false negative is it happens when the model predicts no, but the actual answer is meant to be yes. So in this term, the model is missing something which it is supposed to catch, but it's not catching what it's supposed to. I'll use the fraudulent detection system again as an example. So if the model says the transaction is not fraud, it's not a fraudulent transaction, but it is actually fraud, then there's a there's that it means that that's a false negative. And these kind of errors are they are usually very serious because it could lead to loss of money, could lead to loss of properties, and because of the model failed to detect important cases. So false negative, it it showed us when the model is not sensitive enough and it is missing something that needs to be positive, and we need to try to avoid these kind of mistakes. So we also have true negative. So please, I also want to confirm if you can still hear me. Please, if you can hear me, you can unmute your mic and then just say something. Hello.
I hear you.
Hello. All right.
We can
Thank
hear
you.
you.
Thank you very much. Thank you very much. So we also have the true negative. The true negative happens when the model predicts no, but the actual answer is also no. So in this term, the model is actually correct. It is a correct negative prediction, and the model is correctly identifying that thing that it's identifying that thing that is not a positive case. So in this case, our model is correct. So back to the fraudulent detection system. So if the model says the transaction is not fraud, and it is truly not a fraudulent transaction, so it means that it is a true negative. And then it shows that the model is handling this it's handling its predictions correctly, and yeah, it is handling its predictions correctly. So next thing we'll be talking about is precision. So precisions are also very important when it's also very important cases we need to be able to understand when we train our model. Also very important. So now we've been able to understand the different types of predictions. That's the true negative, the false negative, and the true positive, and we'll be able to understand them. And we need to also be able to understand what precision tells us. So when the model predicts yes, like precision is precision basically it tells us when the model predicts yes and how often it is actually correct. So the model could predict yes, but it is not actually a correct answer. So the prediction doesn't just look at the amount of yes we are having, doesn't just look at the amount of results that are having yes. It checks if that yes is actually a correct yes. So precision focuses only on the predictions where the model says yes, and it also checks how many of those yes are truly positive, how many of those yes are yes and they are supposed to be yes, not just being yes but supposed to be no. And when you train your model and your precision is high, so it means the model is very accurate. It means that if we don't really need a cause for alarm. But when you train your model and your precision is low, so you could have a lot of yes and your precision could still be low. It means that you are having your system is the model you trained is just giving us a lot of positive, but a lot of those positives are actually wrong. And when your precision is low, you need to there's supposed to be cause for alarm. We need to like check and probably retrain the model and make sure that the model is actually giving us the correct results. So we need to make sure that our precisions are always very high. They are very important in important situations where you're having false positives. It could cause a lot, and we need to avoid those kind of things. So we need to avoid it as possible as we could. Now, next slide, we'll be talking about recall. Recall basically tells us how well the model is able to find all the actual positive cases. So as I said, all these metrics are very important. They have each they perform their own they do different things, and each of them are very important. So could say out of out of everything that is truly yes, it checks how many did the model successfully detect. And if your recall is high, it means the model is catching most of all the real positives. And it means it's not missing important cases. But if your recall is low, it means the model is missing so many positive, which can be a serious matter. So when training our models, we need to take note of this, that precision needs to be high. Our recall also needs to be very high, because when it is not high, it could cause serious problems depending on what we are working on. If if it is if it's something that would cause people's information or private people's money, we need to take note of this. So recall is important. It's important in situations we need that we check our recall to know if we are missing, if our model is missing positive cases. And just like the fraud detection I spoke about, we need to know, because if okay uses this face verification, and if the face verification is not able to identify the correct user properly, it could cost them a lot. So these kind of things are always very critical. The next thing we'll be talking about is accuracy. Accuracy, just like how the name implies, accuracy means correctness. Accuracy means correctness. So accuracy, basically it measures how often the model is correct overall. It measures how often the model is correct overall. So it looks at the predictions, both the yes and the no. It doesn't just look at the yes or only the no. It looks at both the yes and the no. And then he checks how many of them are correct. So the accuracy goes through the when you see your accuracy and then your accuracy is high, it means that the model is it's making correct prediction. Because if you're having a lot of yes and you're also having a lot of no's, and the yes and the no are correct, so the your accuracy has a very high chance to be high. But if you're having a lot of yes and most of them are not actually supposed to be yes, so this thing, it measures the yes and the no, and then it measures them that, okay, how correct are they? So overall, it measures your model predictions and check the accuracy. How correct are they? Is this yes supposed to be yes? Is this supposed to be no? It checks it, and it gives us your accuracy results. And if it is yes, you should know that. If it is very high, rather, you should know that your model is doing a good job. But when accuracy is low, as the name implies accuracy, you should know that your model is not predicting the accurate information. It's not predicting correctly. So we should also know that accuracy can sometimes be misleading. Why I say that? Because especially when the data is imbalanced. But for example, if most cases are no, a model can get high accuracy just by always predicting no, even though it's not actually useful. So why accuracy is a very helpful metrics, we don't usually need to rely on it alone. So we need to combine it with other metrics like precision and recall. So we shouldn't just look at our accuracy alone and check if the accuracy is high. And once your accuracy is high, you conclude that your model is doing a great job. No, it doesn't work that way. That's why we also have precisions and also recall. So you also need to combine those others metrics, the precision, a recall, and then get a better understanding of the model's performance. So when we are training, we need to make sure that if the accuracy is high and your precision is very low, there's a cause for alarm. You need to check and understand why your precision is low, because precision needs to be high for us to be able to be sure that the model is doing a good job. So we have the next thing that we'll be talking about is F1 core. Is F1 score. But before I proceed, I don't want to keep talking. So I want to know if there's any question from anyone. I want to know if there's any question. So we could tackle that, or I'll just proceed with the training. So any questions so far from what we've learned on model scaling, model serving and scaling, the confusion matrix, precision, recall, accuracy. Any questions so far? Because I can't see any question in the chats. Okay, I'll proceed. So next we have F1 score, which is the balanced matrix. F1 score is is a way of combining precision and recall into a single metric. So when your result comes out, you would see the precision, you see the recall, you also see the F1 score. So the F1 score combines the precision and the metrics into the precision and the recall into a single metric. So instead of looking at them separately, it gives us one score that reflects how well the model is balancing both. Don't know if you're getting me. So it gives us one score, one score, and then with that score, we will be able to identify how well the model is balancing both the precision and recall. So if a model has a really high precision, but the recall is low, or it has a really high recall, but precision is low. So the F1 score has a tendency to reflect that there's an imbalance in the results. So because the recall and precision needs to be both high, but if one is high, one is low, your F1 score is is going to reflect that there's an imbalance. So it is useful when you want your model to perform well. So it's good to use the F1 score when you want your model to perform well. So in that case, it is able to detect the positives and then also avoid cause for false alarms. We can see the formula for the F1 score is the precision times recall over precision plus recall. So this now is going to tell us how the model how balanced the model predictions are, if the predictions are balanced or if they are imbalanced. So in simple terms, we could say the F1 score tells us how balanced the model is between being correct when it predicts yes and being able to find all the real yes cases. Are you with me? So the F1 score is also very important. So we're able to know how balanced it is. We're able to measure because you see your prediction, you see the metrics, and sometimes you might get confused. So through the F1 score, you're able to check how balanced your model is able to predict correctly. So we have the threshold. Threshold is very important because we've talked about precisions, we've talked about recall, accuracy, we've also talked about F1 score, and everything is saying that it needs to be high, it needs to be high, it needs to be high. Now we need to understand how threshold actually affects the behavior of our model, how it affects the results. So we we use threshold to know how sensitive, like we use it to know how um, sensitive the predictions are. That means it's it predicts more positive. So if it predicts more positive, it's going to catch almost everything. Then that means it's going to lead to a really high recall. But if it also increases false alarm, which also can lead to lower precision. And then our threshold is also generally threshold standard. It's supposed to is supposed to be very close to 1, because when you have a threshold that is very low, like you're having 0.0000 something, that's a really bad score for threshold. So having that kind of threshold need to we need to we need to know that there's a cause for alarm. We need to know that our model is not predicting accurately. So we threshold, we use threshold generally to control the the balances, like we control the trade-off between the precision and the recall. So if we adjust the threshold, if we check the threshold and then we adjust it, we'll be able to see what is changing. We'll see the change, what is changing the model itself, and then we're able to also see how the model makes decisions. So as I said, the threshold needs to be close to 1. So having if you're training two models and then one model is 0.001, and then there's another model that is probably 1, or it's very close to 1. So the threshold with a higher model that is closer to 1 is better than the one that is far, far, far away from 1. That's the threshold that is really low. So we have low threshold and then we have high threshold. Okay, so we have low threshold and we have high threshold. And we need to understand um low threshold and high threshold. So we were able to understand when our threshold is low, what is actually happening, how is the prediction going, and then when it is high, we need to also understand how the prediction is going. So when we use the low threshold, when model becomes more sensitive, that means the prediction is more positive, as I said. So it catches almost everything, and then it leads to a high recall. But also it increases the false alarm, which is a lower precision. And then here, when the threshold is high, on the other hand, could say that um the model is becoming more strict. The model is becoming more strict. So when it predicts more yes, when it predicts yes, it means that the model is becoming more confident. And when the yes are becoming more, we understand that our model is becoming more confident, and it improves the precision, because the predictions are more accurate. But if it misses the real positive, then it's going to take us to a lower recall. I don't know if you understand what I just explained now. So threshold, we just use to control recall and the precision. When the threshold is low, we check it, check the precisions and the recall. When it's high, it also affects the precisions and the recall. So here we have precision versus recall. We've talked about precision. We've also talked about recall. We've talked about precisions, and we've also talked about recall in this class. And so I said that the precisions, it checks the yes and how correct the yes are. And then also the recall also, it checks the yes and it checks the no, and it it balances it. So most times when training model, based on experience, I've understood that when you try to increase one of them, it affects the other. So when you're training a model and then you increase the precision, sometimes it affects the recall, because the recall has a tendency to reduce. And if we try to improve the precision, the model becomes more careful about saying yes. Like it becomes more less confident when you try to have a very high precision, and with that it reduces the false positive. And in doing that, it can sometimes miss some real positive cases which it is supposed to catch, and it can lead to a lower recall. So that's why we need to be able to balance these things and be able to be careful on how we like be able to balance it, so that we don't end up increasing the precision too much and it starts affecting the recall, and the recall starts becoming low. It could affect the general performance of the model prediction. And then also, if we try to improve the recall, also the model becomes more aggressive, and then it tries to catch all the positives. So it is just the behavior, like it's now has a tendency to try to catch all the positive, and in this case now it can reduce the it can miss some cases, and also increase false alarms, which can lower the level of precision when there's too much false alarm. So generally we should be able to balance it, and then try to maximize both at the same time, and don't just focus on the recall and leave the precision, or focus on precision and leave the recall. So as we keep training our model, we need to try to balance it and make sure that our precision is and the precision and recall are balanced enough, and no one is being affected. So now we're going to understand when to use each matrix. We're going to understand when to use each matrix. So when to focus on recall, when to focus on precision, and then the balanced F1. And it's a very important one to understand. When we are training our model, we need to understand, okay, when are we going to use this matrix? When do we need to focus on this matrix and make sure that it is because it increases? We need to be able to know when to use it. So we don't just use all the metrics in every situation. So we should be able to choose them based on the problem we are trying to solve. Because you could build your model for different reasons, maybe for object identification, or for fraud detection, or for spam messages, depending on the problem you are trying to solve. So in this case now, we should know the situations, and should know when to choose and when to focus on anyone based on the problem we are trying to solve. So if you're working on something like a medical diagnosis, it's important that we care more on the recall. working on medical diagnosis, you could want to focus on the sick patient. Maybe you don't want to miss any sick patients. You're focusing on that. So even if it means that some patients are healthy, even if it means some patients are healthy, we want to focus on the recall so that but no, it doesn't flag any mistake and miscalculate, maybe misidentify a sick patient to a healthy patient. So it's good to focus on the recall on critical situations like that. And then if we're working on something like spam detection or fraud alerts, it's good to care more on precisions. So in this case, we don't want to make mistakes or maybe probably do something to annoy our users by giving them false alarm. And we need to make sure that we are, if not 100%, but at least a good amount of percentage correct in the predictions and in the predictions. So that when we say something is suspicious, it is truly suspicious, and we don't just identify a identify something as suspicious when it's not suspicious. So I would say I'll use example this face detection also. If you're trying to, maybe you want to do something and then it's asking you to put your face, wants to detect if you're the rightful owner of the account, and then you are placing your face in front of the camera and you're doing everything it's asking you to do, and it's still telling you no, that you're not the real person. Sometimes it could be frustrating to the user, and it could be annoying and could lead to something else. So this in these cases we don't want to frustrate our users or frustrate the person using that's going to use the model you're training, right? So we should we as that we'll focus on the presentation so that we'll try to be as positive as always, so that when it is positive, it is actually positive, not saying this is a wrong account, meanwhile it is not a wrong account. Okay, please once again, I want to confirm if anybody can hear me. If you can hear me, just unmute your mic and say something.
I hear you.
All right, thank you. So as I said, we focus on precision when we don't want to raise a false alarm. We don't want to say this is a fraudulent act, meanwhile it is not. And then just tell the user this is not, maybe if someone sends you an email and it's not supposed to be spam and it is telling you that it is spam. So you could make the user panic unnecessarily, which is not meant to be. So precision is always making sure that everything that your yes is actually yes, it is truly yes. So when you say yes, your user should be able to be rest assured that okay, this is actually yes, and not yes or no sometimes. So we have next we have evaluation curves. We have evaluation curves, and so far I've spoken on on how to when to use and how to be able to understand what performance to focus on, and then also be able to understand the metrics like precision, recall, accuracy, and then now we want to take a step further and want to I want us to understand evaluation curves. So, evaluation curves, this, it just trying to tell us that our metrics can change depending on the threshold we choose. So, the so um so when you have a number in for like a single number for precision, it could change depending on the threshold. So that is where evaluation curve comes in. So when you have a number, it doesn't always like give you a full picture of how the model behaves. It sometimes changes. The model predictions sometimes are not always static. They're not always static, so the changes. It changes. So as we keep proceeding, the prediction changes. So we need to monitor and then know how correct they are depending on the threshold. So that's why we use evaluation curves. The evaluation curve here is it it shows us how the model performs across different thresholds. So when your threshold is 0.2, your precision and recall is going to be a different number. And then if you increase your threshold, you make it um 1, your precision and recall also changes. So we use the evaluation curve to understand the behavior of the trace of the prediction based on different threshold instead of just one fixed point. So we don't just use it's not just static. We use the evaluation metric to understand based on different threshold. And then this evaluation curve is very important because it's going to help us to understand the full behavior of the model. This helps us to understand the precisions, our recall, and how they change, and then we're able to make the model more strict or more flexible depending on what we want. So if it helps us to be able to understand. So instead of just looking at one result, we're able to look at the different performances across many possible decisions. We're able to check the different performances for each of them based on different decisions that based on different decisions from the prediction, based on different when the we're able to understand, okay, when the precision increases, this is what happens to the record, this is what happens to the accuracy, this is what happens to our threshold. When the threshold changes, this is what happens. We're able to understand based on different decisions. So is that it's good to always work with evaluation curves. So we have the precision reform curve, we have the ROC curve, and the ROC curve is the receiver operating characteristics. So it's these curves provide different pictures of the model performances based on the decisions, based on the threshold. So here is the precision recall curve. So the precision recall curve, it's it shows the relationship between the precision and the recall at different threshold values. The precision recall curves gives us the relationship between the precision and the recall. As the name implies, precision recall curves. So it checks the relationship of the precision and the recall based on the threshold value, based on different threshold values. So as the threshold values increases or reduces, it helps us to understand the behavior of the precision and the recall and understand their relationship. So instead of looking at just one precision and then recover and one recover value, we are able to see how they change as we adjust the threshold. We're able to see how each of them changes as the threshold changes. So this is how the graph looks like. This is how this is the graph. So based on this graph now, this axis is the precision, that's the blue one, is the precision, and then
Sorry, there's no graph. I can't see any graph.
okay, you can't see this where my mouse is. Can you see my mouse?
So we can see your mouse, but we can only see
No,
F1,
no graph.
the balance matrix.
You can see F1.
F1's for the balanced matrix.
Oh no, that's not what I'm presenting.
Yeah, maybe your system is lagging a bit. Just try and stop resharing and reshare so it will work properly.
Okay, but can you see the precision recall curve? Can you see the right of precision recall curve?
That should be like slide 10.
No, I'm not in slide 10. This
Wait,
slide,
what slide is that?
this slide 16.
Oh, we can't see it at all. We can only see F1 score. Which is slide 10 here.
Oh, oh, you're still seeing slide 10. Oh,
Yeah, so
I'll
probably just
share.
stop
Let
sharing
me
and
stop
share
sharing.
and put it on the presentation mode so it will be easy.
Okay, but do I need to go back to explain from slide level? Because, okay. Okay, can you see my screen?
We can't see it yet. It's still loading.
Hello, can you see my screen?
We can't see it yet. It's still loading.
Okay, it's probably the network. Can you see my screen now?
Yes, we can see your screen, but it's just showing the zoom.
Okay, but you can see the F1 score.
Yes.
Okay. Okay, so it's obvious I was presenting the others, but my screen was not
Just do
presenting. But
a speed
so
run
far,
for the ones that have been missed. Did you get that?
okay. Yes, I said that.
All right, thank you. And kindly please put it in presentation mode so it will be bolder and we can see it clearly.
Okay. Okay, so this is where I stopped F1 score. So as I explained previously, the F1 score we use it to combine the precision and the recall into a single metric. It's a way of combining the precision and the recall into a single metric. So instead of looking at them separately, we're able to, where it's going to give us one score that reflects how well the model is balancing both of them. So instead of looking at just no, instead of looking at the precision and the recall, we could check the F1 score, and with the results you're getting from the F1 score, you were able to understand how well the model is balancing both the precision and the recall. So if the model has a high precision but a low recall, or I would say it has a high recall but a low precision, the F1 score will is going to reflect the imbalance, because both are supposed to be at least to some extent high, and there's supposed to be a lot of imbalance in their scores. So if there's a really high precision and then there's a very low recall, the F1 score is going to reflect that there's an imbalance in the prediction result. So the F1 score is useful when we want our model to perform well in both detecting the positives, and then also when we are trying to avoid false alarms. So in that case, we check the F1 score when we are trying to avoid false alarm. We don't want our predictions to give us a false information. So generally, we could say that the F1 score is it tells us how balanced the model is between being correct or how balanced it is, if it is correct or incorrect. It shows us the imbalance of our model prediction. And you can see the how we get the F1 score. It is 2 times precision times recall divided by precision plus recall. So whatsoever we get is it tells us the correctness or the completeness. It tells us how balanced our model is based on the answer we get from this formula. That's 2 times precision times recall divided by precision times recall. Now, next slide, we'll be talking on classification threshold. That's the threshold. We call it threshold. So we have high threshold and we have lower threshold. So these different thresholds we use them to check to determine how the precision and the recall behaves based on the threshold. So if you change your threshold, it affects the precision and the recall. So we have a high threshold and low threshold, but it's good for our threshold not to be too high and not always to be too low. At least our threshold should be closer to 1. I remember I have said that our threshold is to be closer to 1. It shouldn't be too high, and also it shouldn't be too low. So this is the threshold behavior. We have low threshold, we have high threshold. So when we use the low threshold is when the model becomes more sensitive. That means the prediction is more positive and then it's catching almost everything. And it can lead to a really high recall, and also it can lead to a really high recall the threshold is low. It means that it is catching like almost everything. Like it is having a correct prediction, which can lead to a high recall. And then on the other hand, we have high threshold. So high threshold, it predicts yes when it is very confident. So it means that the prediction is now the model is now becoming very confident. When you start having a higher threshold, like your threshold starts increasing, it's trying to tell you that your model is becoming more confident, and then it's now giving you a higher threshold. So, and this can make your precision to increase, to start becoming high. It can increase the rate of the precision because predictions are more accurate, but sometimes you could still miss some real positives. So also, like, that's why I said that it doesn't need to be too high, that it doesn't need to be too low, because when it's too high, it starts becoming overconfident and it's giving us a lot of positives, and sometimes it could affect the general result the of the model. So we just need to know how to control the threshold and know the cutoff, like know when to stop, know the where to stop when we get to a certain precision and a certain recall. So if we adjust the threshold, the the model result changes, the recall changes, the precision changes, and then we need to know when we stop increasing the threshold so it won't be too high. And then also we need to know when to increase it, when it starts becoming too low. So now we'll be talking about on precision versus recall. We're talking on precision versus recall. Um, since there is no question, I want to ask question because I want this class to be interactive. So I want to ask those questions before I proceed. So now we are in the next slide. I want to talk about precision versus recall. So I just want someone to explain precision and recall. I don't want to call names, but if you have something to say, you could just unmute your mic and then explain to us what you understand by precision and recall so far. Okay, I'm still waiting. I'm still waiting. Is there anyone that wants to volunteer to explain what you understand on precision and recall? As I said, I don't want to call names, so let someone unmute and just tell us anything you understand. So anything you say, it's not going to be wrong. So just tell us what your understanding is on this so far. Because we've had other classes, and I'm sure you're not new to these terms. You're not new to precision and recall and threshold. So what do you understand on this? Adid Damola. Adid Damola, please help us.
Sorry, what did you say? Can you come again? My network is glitching a bit.
Okay, so I was saying, what do you understand on precision and recall?
Precision and recall.
Yes.
To my own understanding, I feel precision is when there is a particular or there's an exact target to be confirmed, and while recall is when you have to probably do the process over again.
Okay. So when you have, well, like, what does the recall focus on? Sorry, I'm asking you a follow-up question. So when we have a yes, do the recall just check the amount of yes and the amount of no? Or I want you to understand, to like explain to me how the behavior of precision and recall based on based on completion metric. Adit Damola, are you still here with us?
Sorry, I didn't get the follow-up question correctly.
Okay, I said based on the coefficient matrix that was explained, that's the true the positive yes, negative yes, and also how can you explain precision, the behavior of precision and recall? How can you explain how do they work with the confusion matrix? Okay,
I think
you can go ahead.
I'm getting a little confused, but I think I will just sit this one out and see if someone else can answer it.
Okay, so is there someone else that wants to help us with this? Please, let's unmute and answer. Is there someone else that wants to help us with this? He has already tried, at least as is able to explain what precision and recall is. So now, is there someone that wants to explain their behaviors? How do they behave? Before I move into precision versus recall, there's someone else that wants to explain. Um, Beatrice, are you here with us? I've not heard your voice since we started the session. Beatrice. Okay, Amaka, can you help us with that? You could just say anything, what you understand based on what has been taught so far. If you don't understand, you can ask me your own follow-up question and then I would explain to you.
Yeah, I can try out.
All right.
Yeah, so precision measures the number of positives that are there, and recall measures how well a model is able to get those positives.
Okay. Okay, that's very brief and correct. Thank you so much, Tony. Thank you so much, Tony. So he's correct. He has explained it briefly to us. The behavior of precision. So it just tells it measures the amount of yes that are actually correct. It doesn't just check the yes, but then it checks how correct it is. So that's the behavior of precision. So we'll move into precision versus recall. So we'll move into precision versus recall. So as I said previously, that improving one of them can affect the other. So that's why we need to know, as you're improving it, you're training your model and then you're having different results at all. Then you should know when to focus on improving the precision, when to focus on improving the recall. But however, as you are improving them, you should be able to know when to stop, because increasing the precision can decrease the recall, which can affect the model predictions. Then also increasing the prediction too much can also affect the precision by decreasing it. It can also decrease the prediction. I will say this again. When you try to improve the
Hello, sorry, is it me? I can't hear anything.
Hello, Miss Mercy, if you're speaking, we can't hear you. I guess she's having some network issues. Let's just give her a few minutes while she reconnects and gets back on the call. Please kindly hold on a few minutes. She'll be back on the call shortly. She's trying to toggle her internet and come back on.
Okay, the next session we're going to be focused on now is going to use each metrics. So we need to understand when to focus on improving on just the recall, and when to focus on the precision, or when to focus on the balanced F1. Because sometimes we don't really need um we don't really need all in every situation. Like we don't really need to focus on all in every situation, depending on the problem you're trying to solve, right? So yeah, there are some specific problems whereby you would need to focus on the precision. If you are more focused on having the true positives, like you are more focused on the yes that are actually yes, so you focus on precision. For example, if we're working on a fraud, if we're working on a medical diagnosis, the example I used earlier when I was explaining this. So and you care, it's better you should care more on the it's not really better. I won't say it's better, but when you're working on something like that, it's good to care more on the recall, because you would want to you won't want to mix your sick patient with your healthy patients. So at this point, you're working with both yes and no. So the recall checks the yes, checks the no. So it's good to focus on the recall. And then if you're working on something like a fraud detection, or maybe if you want an alert when there's a spam message, that is a spam message detection alert. So it's good we care more on the precision, because in this case now we don't want to do anything that would make our users panic unnecessarily, by probably giving them a false alarm. So we focus more on the precision, because the precision just checks the truly yes, and it checks just the yes that are actually yes. Like if we end up giving out information, maybe there's no fraudulent attack in a user's account, and then you send out a message that, oh, there's an attack in your account, you could make the user to panic unnecessarily, and the user might even end up probably blocking that account or doing something that isn't supposed to be. Meanwhile, there was no fraudulent attack. I've also used the face detection as an example. So if you want to do something, and then you are required to scan your face, probably it wants to scan through your face to identify the person that wants to make that action. And you're putting your face there, you're setting the camera to your face, and it is scanning through your face, but then it is telling you that it is saying this is not the right person. It is flagging red, not allowing you to be able to have access to your account. And in this case, it depends on how the system is being programmed. In this case, it might even end up blocking that particular account, saying that there is a fraudulent attack, or probably an unknown person wants to access that account. Meanwhile, you're actually the one. But this is the model. It's not detecting that you're the one. It's in dating you are the one. So that's why we need to focus on the precision, because precision will actually check the yes, and the yes that actually yes. It will not check yes that are no. So it's to check the yes that actually yes. So situations like this, we need to focus well on our precision, so that we don't wait a cause for false alarm, and then also we don't want to annoy our users. We don't want them to panic unnecessarily. So you should know the best metrics to focus on depending on the problem you are trying to solve. So our next slide is the evaluation curve. So the evaluation curve is a graph. It's kind of like a graph where we were able to understand the behavior of our metrics based on depending on the threshold. So depending on how the threshold changes, we're able to understand the predictions, the behavior of the model predictions based on the threshold, based on the amount of threshold. So our metrics changes depending on the threshold we choose. So the precision, the recall changes depending on the threshold you choose. So um focusing on a single number, focusing on a single threshold, but not it might not actually give you the full picture of the model's behavior. That's why we need to check based on different thresholds what is the behavior of this model. That's why we have the evaluation curve. Gives us the leverage to check based on a particular threshold, what is the behavior of our model? How is it responding? How are the metrics responding? So evaluation curve, it shows us how the model performs across different thresholds. Instead of we just checking it from one fixed point, it gives us different thresholds, and then we're able to check how their model performs across different amount of thresholds across different thresholds. And then it also helps us to understand the full behavior of the model. We're able to understand how the model behaves. If our threshold is high, how is the model behaving? When the threshold is low, also, how is the model behaving? And also, especially how precision and recall change. So as we make the model more strict or more flexible, we're able to understand how the precision and the recall changes instead of looking at just one result. So here we have the precision recall curve. Precision recall curve. As the name implies, precision recall. Precision recall. So it's all about precision and recall. And it's so this precision recall curve is like a graph that shows us the relationship between precision and recall at different threshold values. You can see this graph here. So this is how the precision recall curve graph looks like, something like this. And when you see it, we're able to understand this is the precision, and then we're able to understand how the precision and the recall behaves based on different threshold values. So instead of looking at just one precision and recall value, we are seeing how they change based on the threshold, because the model is going to it's going to behave on different threshold levels. And this curve now help us to understand the relationship of the precision and the recall based on those threshold values. And as I said, that when the recall increases, there's a tendency that the precision might decrease. And when the precision decreases, the recall might increase. So this curve, it's just useful because when we have this, we're able to understand the imbalance. We're able to understand the imbalance of the data set the model is the results of the model. We're able to understand the imbalance. We're able to know um the one that appears much more than the other. We're able to know how high precision is based on different threshold, and then how recall also behaves based on different threshold. So, and for us to have a really good model, as I said, the precision and the recall needs to be both high. That's why we need to know how to increase and how to increase each of them so that it doesn't affect the others. Because to have a really good model, we need to keep both precision and recall high across different thresholds. So when we check across different thresholds, we should be able to see that our precision and our recall are still high. They are not going too low, because having a low precision means your model is not responding properly. It means that the model is not having a lot of positive yes. It means that there are a lot of yes, not but it is not actually supposed to be yes. I don't know if you understand what I'm trying to say. So the next slide is ROC curve. So this ROC curve. So the ROC curve basically stands for receiver operating characteristics. So we call it receiver operating characteristics curve, and it is used to measure how well our model can distinguish between the two classes. That's between positive and negative. It helps us to be able to understand how well the model is able to distinguish when to is able to distinguish positive and negative. So on this graph, you can see that we're able to compare the true positive rate, which is the same as the recall, and then also the true positive rate against the false positive rates at different threshold values. So you can see we're able to identify the true positive. This is the true positive rate. This with the blue line, and then the random guess, that's the false positive rate. The false positive rate. So we're able to identify each of them between different threshold values, between different thresholds. How is the positive rate? And with this, we're able to understand how our model behaves, the behavior of the model, and know if okay, if this model is responding how it is supposed to respond. So instead of just focusing on on one, we're able